Hello everyone, my name is Orkodip Mandal. I am from West Bengal, India. Currently, I am doing my BTech in the field of computer engineering from NIT Kurukshetra. Now, coming back to this video, in this video, I will be doing my screencast of my virtual participation of the Atcoder beginner contest 235. The contest was held actually I think 5 or 4 days ago, and I was not able to participate in that contest during the contest during the actual time of the contest, but I will participate in that contest virtually now, and you will be able to see my thought process of the problems throughout the contest. Wish me good luck. Thanks. Let's start. Okay, so tasks. Let's open the first 4 problems first. Problem rotate. Let XYZ denote the 3-digit integer whose digits are XYZ from left to right. Given a 3-digit integer, none of whose digits is 0. Output ABC plus BCA plus CAB. Simple input, simple output. Okay, got it. So it's a pretty straightforward problem. We can just take input as a string S, scene S, parallel I equals to 0, I less than n plus plus, parallel j equals to 0, less than 3, where j is the 3, since 3 will be the length of my string. Then current equals to S of I minus 0, and here if j equals to I will just do continue, and then else what I will do is that current into equal to S of j minus 0. And finally what I will do is that answer plus equal to current Cout answer, and then answer equals to 0. Let's check for the sample input. Answer should be 666. Input P 999. Okay, so it's giving some errors for should be error. Okay, got it. I got the mistake here. It should not be there. So I made a mistake that I put it here. Now I think it should be fine. 2187, that's 2187 ABC plus BCA plus CAB. Find equals to S of I minus 0, current into equal to. Okay, so what I'm doing is that, why is it wrong? 9 into 9 is 81. 9 into 9 into 9, 81, 9 is 720 into 3, 2187 should be the answer. Why is it 2987? Okay. Shit. I mistaken the problem. Sorry. So I realized my mistake here. Got it. So here, what should be the case? A into. Okay. So I should just print like this. Answer equal to S of 0 minus 0. Okay, so let's do like this. Let array equals to B equal to S of 1 minus 0 and C equal to S of 2 minus 0, and then answer equal to A into B into C plus B into C into A plus B into C into A plus C into A into B. I mistaken the problem. Shit. A into 100 plus B into 10 plus C plus B into 100 plus C into 10 plus A plus. Okay, so I think for every number basically I have to do this thing. B into 10 plus B plus C into 100 plus C into 10 plus C. Now I think this should be fine. 2997, cool. For the first test kit it should come out to be 666. Control A, Control V, Control V. I think this should work. 66 is the correct answer. Let's output in C++ GCD this and submit my code here. This should give me the correct output, I think. Yes, AC. Now moving towards problem B here. There are n platforms attached in a row. The height of the ith platform from the left is h of I. Takahashi is initially standing on the leftmost platform. Since he likes heights, he will repeat the following move as long as possible. If the platform he is standing on is not on the rightmost one, and the left platform to the right has a height greater than that of the current platform, step onto the next platform. So what will happen is that from 1, whose height is 1, next platform 5, then 10. Okay. I think I got the problem. Which is a height greater than. Okay, not it. And another very easy problem. No need of explanation, I think. If a of I greater than answer equal to a of I, else break. I think that this should be it. Control A, Control V, Control B. Control C, Control B. Copy. Okay, Control V, Control B. Control A, Control C. Let's submit my code here now. V. Answer should be initialized to of 0, and then answer be of I, else it should be break. I think they should also give me the correct output. Correct. 1 out of 20 test cases per 12 out of 20 pass is equal. Problem B I solved in around time only 3 minutes. That's cool. Now coming towards problem C. You have a sequence of n numbers n. Process the q queries explained below. Query I. You are given a pair of integers xi, ki. I think my OBS is recording everything. Yep. You are given a pair of integers xi, ki. Let us look at the elements of A one by one from the beginning, A1 and 2. Which element will be the kith occurrence of the number xi? Kith occurrence of the number xi. So what we can do is that we can just and all the numbers, we can just keep a map of those numbers. Yes. Just keep a map of those numbers, and I think everything will be good then. First we should take the input, and I will be using one based indexing here, since it will be helpful while printing the answer. So if I now what I should do is that input should be like this. Okay, nq in xk, q, sin n, q minus 1 means there would be some index, there would be val, and I have to find its occurrence. Sin val, occurrence. So now print answer. Firstly, what is to do that? I should just keep a map of those numbers. I think I don't need this vector also. Map of ll comma vector of ll of h, just limit h, lx sin x h of x dot pushback I. Now what I have to print is that the with the kith occurrence. Okay, if h of val dot size less than 0 is less than occurrence, cout minus 1 else cout h of val occurrence minus 1, since that should be 0 based indexing. I think I have to print them in a separate line or in a new line. Cool. Let's check sample test case. Control V, Control P. Is it okay? 1 to 5 minus 1, 1 to 5 minus 1, 3 6 minus 1 minus 1. Cool. Let's check the other given input, 2 minus 1. Control P. 2 minus 1. Cool. Control. The problems are pretty easy today. I think every problem is requiring just a simple implementation up till C. Further I don't know. Second or 16 passed. AC. Cool. Problem is done up till C. Let's check my standings on. I will check the virtual standings actually. What is my standing here? Cool. 43. Great standing up till now. Tasks. So now let's focus on the problem D and problem E now. D and problem E. We have a positive integer a. Additionally, there is a blackboard with a number written in base 10. Let x be the number on the blackboard. Takahashi can do the operations below to change this number. Erase x and write x multiplied by a in base 10. Okay. See x as a string and move the rightmost digit to the beginning. This operation can only be done when x is greater than 10 and x is not divisible by 10. Okay, so the last number should not be 0 actually. For example, if x equals to and x equals to 3, then Takahashi can do erase x and write x into a equals to 246. See x as a string and move the rightmost 3 of 1 to 3 towards the beginning, changing the number 1 to 3 to 3 1 2. The number on the blackboard is initially 1. What is the minimum number of operations needed to change the number on the blackboard to n? N is pretty small. Okay, since n is pretty small, okay, just a second. Okay, so how to solve it? Let's first remove all of these things. Initially 1, blackboard to n. Okay, so let's think about the problem in this way. What will be the minimum number of operations required to change n to 1? So that will be much helpful for me to think about. Okay, so minimum operations needed to change n to a, it should be if it is not divisible by a, then what I should do is that I should just try to shift the. Okay, so I can just make a dp of numbers. Okay, so what I can do is that I think there will be at most one. I think that total number of operations will be pretty less. I can just keep an upper bound on the number of operations. Like the total number of operations will be at max 1 is 6 or 1 is 6, I think. 1 is 6. 1 is 6 will suffice according to me. So let's try that. Let's run a queue vector of bool is of 1 is 6 plus 1. Let's make it 1 is 7 to be sure about it. I think this should work, and I can, okay, let's first make it 1 is 6 only, and let's make a queue of q dot push 1 while not of q dot empty and current equals to q dot fi q dot pop if current into x. Let's make it 1 is 7. Okay, since the number, if the number is greater than 1 is 6, then there is no way I can get it greater than. Okay, so the number must be less than 1 is 6. So if current into x greater than 1 is 6, okay, if current into x greater than 1 is 6 is less than 1 is 6, and then not of this of current into x, this of current, this should be current into a. So current into a equal to 1 q dot push current into a, and now string current if now of now dot size minus 1, now of level of now dot size minus 1 not equal to 0, now equal to now dot sub str 1 comma 1 plus now dot sub str 0 comma 1. So error current equal to string to integer. Let's convert it back now. Current equal to sty now, and if not of this of current q dot push current. Okay, and also I have to make it a pair actually, because the q should also show the answer for that also. 1 comma 0 from the fi lel count equals to q dot from dot sc, q dot push current into a comma count plus 1. This should be it, current comma count plus 1. Okay, this should be inside this function. Yep, now this is cool. Okay, and now answer equal to minus 1. Okay, if current equal to n, answer equal to count, right? And if it is not possible, then just put answer, and it should be minus 1 actually. 372. Play control V. You could possibly be here actually, I think. It doesn't matter actually here, but still. Okay, and here this should always be current into a less than 1 is, and not piece of current here. This should be it. 4, that's giving correct output 25. That should be minus 1. and it takes some time actually to get to the correct output, I think. Okay, got it. I made a mistake here. Phase of current should be coordinate 1 here. Why is it taking so much long time? My customer, it's taking some time actually. I'm not sure whether it will pass or not. I think the number of operations will be pretty low, but if I get time limit exceed, I can reduce the number of operations. This is giving wrong answer. This is bad. 276090. I can only shift it, erase S and I take into A, erase CS and move the chain amount to 3. Beginning. Rightmost D to the beginning. Okay, so I wrote the, yes, I wrote, I mistook here. Plus this should be this. Yes. Now the answer should be 111, I think. Okay, this should be -1. Why? To 611. Control V. Everything is giving -1, bro. Okay, so this is bad. Let's check 372. Control A, Control V. This is also giving -1. Okay, so this is bad. The last digit. Okay. So this is not correct. This should be n -1, 1 plus. Okay, no. This should be 1, okay. Then n should be equal to alien should be equal to length, and this should be alien -1, 1 plus 1, alien -1. Now I think this is correct. Still 24. Okay, so let's check for each. Let's print the debug current. Current equals to 1. Current from 1 towards 3. From 3 we can go towards 9. From 9 we go towards 27. 27 we can go towards 72. 72. How can I get 72? The index at this position. Okay. 8 -1 plus number here. 1. Okay, so this shit. I made a mistake here. 0 -1 this should be. No, I think that should be correct. 4. Yep. This is giving correct output. Let's check this one. I'm not sure whether it will run under the given time limit or not, but I am quite optimistic. Yep, it's taking a lot of time to do actually. So getting the correct output, it's taking a lot of time to compile. Okay, so I'm actually printing those results, so that's taking a lot of time. That's also the case. So let's now just try to submit my code. It may give me time limit exceeded actually. I'm not sure whether it would pass or not. 12 or 20 AC. Okay, so it passed. Cool. Okay, so I got 15 rank, bro. This is insane. Up till now I am doing very good. Solve 4 problems in under first problem took me a lot of time, for my second 3, third 3, fourth 13. Cool. That sounds great. Let's now move towards problem E and problem F. E and problem F. So now comes, I think, some good problems. Yeah, this is a very long problem. I think from now the problems will be pretty good. Let's check the virtual standings one. Okay, so not a lot of people have solved the fifth problem. Okay, given is a weighted undirected connected graph G with n vertices and m edges. Given is a weighted undirected connected graph G with n vertices and m edges, which may contain self loops and multi edges. Okay, it may contain self loops and multi edges. Okay, cool. The edges are labeled as vertex 1, vertex 2 up till vertex n. Cool. The edges are labeled as up this. Cool. Edges I connects vertex ai and bi and has weight of ci. Here for every pair of integers I and j, ci not equals to cj holds. Okay, cool. Okay, so every weight is different. Process the q queries explained below. The ith query gives a triple of integers ui, vi, wi. Here for every integer I such that j less than equals to m, wi not equals to cj. Cool. So every weight should be different, including the queries given in the including the particular weight given in a single query. Let ei be an undirected edge that connects vertex ui and vertex bi and has a weight of wi. Let ei be an undirected edge that connects okay. Consider the graph gi obtained by adding ei to g. It can prove that the minimum spanning tree of gi is uniquely determined. Does di contain ei? Print the answer as yes or no. Note that the queries do not change even though the query considers the graph obtained by adding ei to g. The g in other queries does not have ei. Okay, got it. So this is a pretty interesting problem. How many people solve this problem? What is problem F? Given m digits of ci, find the sum module of all integers from 1 to 18. This is a bad problem. Let's see. I think problem E is a pretty good problem. Only 4 guys have solved it, and it is a pretty good problem by saying given is a weighted undirected connected graph G with n vertices and m edges, which may contain self loops. Given is a weighted undirected connected graph G with n vertices and m edges, which may contain self loops and multi edges. The vertices are labeled as vertex 1n and the edges are labeled like this. Edge I connects vertex ai and bi and has a weight ci. Ci not equal to cj whole square. You had vi. It can be proved that okay, since every weight is different, it can always be proved that the minimum spanning tree of gi will be always be uniquely determined. Okay, that is right. So initially also the minimum spanning tree will also be uniquely determined initially, and initially okay, so initially it may or may not contain. Okay, so I think it's not that much of a good problem as I was thinking, because the weights are different, so it is not that much hard to think about it like this. Initially I will get a single I will get some I will get some tree structures, like there will be one tree here, another tree here, and all of these trees will be unique, because since all of the weights of the edges are different. So I will get some disconnected components of trees initially. Then if I would like to add that edge, now if that edge okay okay so what I need to find is that okay so what I need to find is that if both tree of ti of gi, just a second, okay, am greater than equals to this much, the graph G is connected. Okay. So initially the whole graph will be my whole tree will be connected. Now if I would like to add an edge, then I have to just consider the path from U to V. Let's say that this is the path from U to V, and in the path from U to V, and if the minimum edge, and in the path from U to V, if there is an edge which I can remove, okay, so I am actually adding an edge between U and V. So the path from U to V and that edge will form a cycle. Cool. And so if the path from U to V contains an edge greater than and the weight of the weight of U, then we can erase that edge and add this U instead, and this will not make my graph disconnected. Yep, this will not make my graph disconnected. So to do this, we can do something like what is that thing called binary lifting, and using binary lifting we can find the path from this node. Okay, so I got it. I think I have some. How many people solve this problem? Very less people. So I think I can solve this problem like this. So I can use binary lifting here. I think I have some code written for binary lifting actually, while I was trying to do central decomposition, something like that. Or is it not written? Central decomposition code method compute LCA. Okay, छोड़ो इसको, कोई नहीं, फिर से लिख लेते हैं, कोई क्या दिक्कत, ठीक है. Okay, so let's start. So NMQ U comma W, V comma W. So I have to find the maximum weight and the minimum weight, and if it is greater than and let's say in the path from U to V, there the maximum weight is less than this given EI weight, then we will do nothing, and if the maximum weight is greater, then I will just replace. They can't be equal. So I will be now trying to form a binary vector. For each node I will have to give these much things, LCA of n, and how is n? It is up to 2 if 1 if 5. So log 2 20 will be enough, and also I have to keep a maxi to store the maximum age. LCA fn comma vector of ll 20 comma -1. This should be a maxi. Now what should the input be? AM, BM, CM, UVW. Now I have to process the queries. Okay, so while q minus minus let A B W scene A B W. Okay, so now to do this binary lifting thing, I have to do this binary lifting, or there are any other easy options? No, the constants force me to do binary lifting or things like that. Got it. Yep, the constants force me. So I have to find the LCA. LCA equals to find LCA. Okay, so let's first resolve this thing. For LL, first I have to do DFS. Okay, so firstly I have to find the minimum spanning tree. It's a lot of work. So firstly I have to form the tree data structure actually. Okay, so this is not easy. So shit, I have to do a lot of tasks. This is a very bad formula because it requires a lot of implementation according to me. PII ages dot pushback W comma U comma V. PII, it should be L comma PI. Okay, then I have to just sort those ages. Sort ages dot begin comma ages dot end. Now every node I'm going to create some things. So let's keep them as a global. So let's keep all of these extra things as global variables. G ages vector of PII ages, and also another thing should be that these two things I can also make it global. Control C, Control V. Ages can be like this, and this can be LCA comma maxi, LCA comma maxi, and another there should be a DSU parent and DSU release. Okay, now also there should be something like this. I don't need this G actually now. I'll be in need of this G in a later stage. Okay, and also I'll be needing the no. I actually need this G because I have to construct this graph while doing my DSU PI G. So now DSU list. Okay, and also there should be an actual parent. Okay, so that can do like this. Firstly I have to initialize all of these things. Initialize G dot resize n plus 1 ages dot resize n plus 1 G ages LCA maxi LCA dot resize n plus 1 comma vector of 20 comma -1 maxi dot resize n plus 1 comma vector ll 20 comma -1, and also the DSU list, DSU LCA maxi, DSU list, and DSU PA. I need to solve this problem also, and so that's why you need to be pretty fast here, because this is a bad problem. DSOPA dot resize n plus 1 DSU SU lease dot resize n plus 1. Okay, so now I've initialized all of those things. Let's comment here initialize cool. Now what to do is that I have to now do something like this. First you have to construct let's name it as tree only, because it would be a tree, not a graph. Also a graph is a tree, but that's okay. So edges, I think edges, yes, edges should not be resized. Edges should not be resized, edges can be left as it is. Tree dot resize, this should not be done here. Okay, sort edges dot begin, gonna be starting now for auto and p in edges. ll w equals to p dot fi, u equals to p dot sc dot fi, v equals to p dot sc dot sc. If okay, now also I have to initialize other things also. For ll I equals to 1, I less than equals to n comma plus dsu pa of I equal to I dsu lease of I dot spec I. Okay, this is now cool. Now what I have to do is that if DSU PA of U not equals to DSU PA of V, just continue. Otherwise what I will do is that I will just union U comma V, union U comma V comma W, union U V W, right, union ll U ll W. If lease of U, okay, U equal to DSU PA of U, and also V should be equal to DSU PA of V if DSU lease of U dot size greater than DSU lease of V dot size, then I should just swap U comma V. Swap U comma V. Now since U is smaller, for auto and x in lease of U, lease of V dot cosplay x, photo and x in this should not be lease, DSU lease of U. Why this is not, it is giving a wrong answer. DSU lease, okay, so I made it wrong actually. Vector of fidelity should be vector of fidelity lease, okay. Yeah, this is now correct. DSU lease V and DSU PA DSU PA equal to V. So V dot pushback x. dsu pa of x equal to v. Good. Now another thing we just do is that tree of u dot pushback v comma w and tree of v dot pushback u comma w. So now I have got my minimum spanning tree up till now. Okay, so now up till now I have got my minimum spanning tree using Kruskal's algorithm. Now what I should try to perform is that now what I should write for each query. Okay, now I have to consider the path. Lot of things to do here. This is a very bad problem. Firstly I have to do a DFS from the node 0. For a DFS in the node there should be another variable called, okay, so there is no need of this another variable. List of node 0 equal to pa, or also this child in g of node. If child not equal to pa, dfs child node, this should be not g, this should be tree actually, and let's make here -1. Now I have to consider for lift equal to 1, lift less than 20, lift plus plus. For node equal to 1, node less than equal to n, node plus plus. LCA of node lift. Okay, so lift equal to LCA of node and lift -1 if means not equal to -1. Okay, so LCA of node lift equal to LCA of x lift -1, and let's initialize maxi with this infinity thing only. If the minimum is okay, so I'm consider the minimum. Yes. Okay, so this is -1 is okay. Since I'm considering the maximum. Except node lift equal to LCA of mid lift -1, and also this there should be a weight associated with this thing also, tree of these things. Okay, LV LU comma w maxi of node 0 equals to w should be -1 here. -1. Okay, if child dot fi not equal to pa dot fi node child dot ac. Now up to this point everything is cool. Now what I have to do is that, okay, now LC of node lift equal to, and also maxi of node lift equal to maxi of mid lift -1. This is cool. Okay, so now I have to find the LCA of, okay, LCA equals to find LCA u comma v. List of node DSA would this should not be list, it should be LCA, I think. Top root, let's name it root, is to find LCA u comma v. Find LCA, then find LCA LLU comma LLV. Okay, so I do not find the LCA of this. How can I find the LCA? Okay, oh shit. I can't solve this problem. Let's check it once. I'm sure that not many people will have solved it. Yes, it's not that much. Problem E. Yep. So okay, now find LCA U comma V. Okay, so I have to keep their heights also. Lot of vectors to maintain. Vector LVL. Let's also keep pass their height with here. Let H LVL of known equal to H. Let C comma H plus 1. Also have to do LVL dot resize L plus 1. LVL dot resize plus 1. Cool. Now up to this point everything is cool. Now find LCA. Okay, if LVL of U is less than LVL of V, swap U comma V. Okay, LLD equals to LVL of U minus LVL of V for LL. Equals to 0, less than 20, plus plus. If B and 1 less bit, U equal to LCA of U. Okay, now answer. Okay, so let's find the LCA only. LCA of U. What is this thing? This thing should be LCA of U bit. LCA of U bit. Okay. If U equal to V, return U. Okay. For lift equal to 20. Let's say lift equal to 0. Lift minus. LCA of U lift not equal to minus 1 and then LCA of U lift not equal to LCA of V lift. U equal to LCA of U lift. V equal to LCA of V lift. Will find return LCA of U 0. Okay, now to find the maxim. Find LCA U. Okay, so this should be A B V. Find LCA A B LL current maxi equal to calc A comma root comma calc B comma root max of. If current maxi less than W, C out. Okay, so does TI contain EI? Print yes. Okay, so if it is current max is greater than, then we should print yes, else we should print no. Okay, and now max equals to max of calculate these two things. Now to calculate, let's calculate LL known LL root. I have to go from the path from here to you. For lift, okay, so I can just do this thing. LD equal to LVL of node minus LVL of root. I think A and B should be distinct. Yes, okay, so U and VI can be same, but that doesn't matter much. D equals to not parallel. Okay, now the current answer should be equal to 0 for L D equal to 0 for L beat equal to 0 equal to 0 bit less than 20 or bit plus plus if D and formula slash bit node equal to LCA of node bit maxi equal to maxi equal to maxi of maxi equal to max of maxi. Okay, so this should maxi answer should equal to max of answer comma LCA. Max equal to max of answer comma LCA of these two things. So max of answer comma maxi of LCA bit maxi of node bit. Yep, it is going like this, and node equals to LCA of node bit. It's and now what I have to print is that I think I've done some mistakes here. I've done a mistake. If mean not equals to -1 and then LCA of mean lift -1 not equal to -1. Yep, I think now the whole implementation, there are a lot of chances of mistakes here, so let's try and check. They are given a very so let's check this small input. Yes, no should be the output. It will be okay, so it's given the correct output. Yes, no yes should be the output. My code compiled in a one step, bro. This is insane. Okay, it's now not giving the output, so something is wrong here. Okay, so I have to now debug my code. 5631223 okay, LLNNQ CNNQ LVL dot resize, everything resized, DSAPA DCMVW 1 2 3 4 5 6. I've taken input up to this point, and 1 2 3 4 5 6 1 2 3. Okay, let's just check if our code ran up till this or not. Okay, so our code ran up till this point. So if we just remove this thing and do then current is equal to 0, then I think the output will be printed. Okay, something is wrong here. Okay, so in the find LCA function something is wrong. So let's do it again. Yes, it is giving no, so something is wrong in the find LCA function. Find LCA 1,3. okay, find LCA Let's say LVL of v swap u comma v. D equals to LVL of u minus d and a versus less bit. U equals to LC of u bit. Cool. If u equal to v, return 0. LC of v lift. V equal to LC of v lift. Okay, got it. It should be 19 actually, because it was initialized with 20. That is the mistake, I think. Yes. I think that was the mistake. No, nothing else was the mistake according to me. Yes. It is insane, bro. It's giving the correct output. It's giving the correct output. And just a few checks. I have not debugged my code up till now. Yes, no. Let's submit this. Submit. Control V. Let's submit my code here. Okay, wrong answer. It's bad. This is bad. Detail how many test cases passed actually. Okay, so it is completely wrong. My approach is completely wrong actually. This is bad. Not change T. So the 2 to the power 90 will be okay. So what is the mistake? Let's try to find my mistake here. Lift is 20, LCA 3 is resized, 3 LCA maxi DSOP DSL is LVL, 3 LCA and DSOP DSL LVL. Everything resized with these things. DSOP list, AS dot pushback, W comma U comma V. Cool. Sort. This has been sort now. This is also cool. If there are same path continue, else what we'll do is that just make them union. And what does union mean? Union means that U could use V. Okay, no. Okay, so this is wrong. This has to be in the initial step actually. Tree of U dot pushback V comma W, tree of it pushback U comma W, tree U equals of P U, V equals to S of V, S of U comma V, list DS of P of X equal to V, DS of P of X equal to V, yes, DSU PA of X equal to V, that is correct, DSU list of V dot pushback X is also correct. We'll say node 0 PA, this maxi node W. Dual node equals to H, H plus 1, which is equals to W. I think this is correct again. Let's check it once. Yes, no, it is printing. There was a mistake there actually. Yes, it is using the correct output. Control V, let's check it once. So there was a mistake there actually. Let's check it now. Oh shit, again wrong answer. What is the mistake that I'm doing? I think my current is detail. How many test cases passed? Again the same verdict. Have I changed that? Tree of U dot pushback of E comma W. Logic is incorrect according to this. Logic is incorrect. Only one will solve F, so I think I should not try F. And how many minutes are left in this contest? How can I check top? Shit, how can I check my time? Okay, remaining time 35. What I am doing wrong here? So is my total logic incorrect? Does Ti contain Ei? If the current maxi okay, so here is something wrong. Maxi of node lift minus 1 comma maxi of mid lift minus 1. Yes, this is wrong because I have to take the maximum of both those things. Maxi of node lift minus 1 from the path from node to lift minus 1 up this side, and from the mid to the lift minus 1. Again, it is showing cut out. The sample cases are very bad. It is showing cut out for everything. Whatever I do. Let's check it 1 second now. Submit my code now. Control V, submit. This time it might again fail. I don't know. Please don't fail, bro. Okay, 7 test cases passed, 7 passed, 9 passed, cool, 12 passed, SC, cool, accepted. My solution was actually correct. Cool. Let's check the virtual standings now. 23. Cool. Now coming towards problem F. Only 2 of the guys solve problem F. Okay. Problem F, problem G, and problem H. Let's see problem G also. First let's have a break of some minutes, break of 1 or 2 minutes, and then let's start again. I think my screen is recording. Problem E was a pretty implementation heavy problem. Not a lot of things to it didn't require much to think about it, because if you know the things you can solve it. That's it. Tapasi has A apple seedlings, B banana seedlings, and C. Okay, so let's take some break for 1 or 2 minutes. ভেতরে উইকপোর্ট পড়ে আছি, এখন অনেক দিকে ডিস্টার্ব করুন। Okay, so now let's see if we can solve problem G. If we can problem C, we can get at the top. So I think that's not possible actually. F has been solved by only two of the guys. My rank is 23, which is a very good rank. G. Takahashi has A. apple seedling, B. banana seedlings, and C. cherry seedlings. Seedlings of the same kind cannot be distinguished. He will plant these seedlings in his. Okay, so let's see how many minutes are left now. Okay. How many minutes left? Only 30 minutes left. Let's try to get problem G once. At least one seedling. He will plant these seedlings in his n gardens so that all of the following conditions are satisfied. At least one seedling must be planted in every garden. It is not allowed to plant two or more seedlings of the same kind in the same garden. Same garden. It is not necessary to plant all the seedlings he has. There are many ways to how many ways are there to plant seedlings to satisfy the conditions? At least one seedling must be planted in every garden. Cool. Is not allowed to plant two or more seedlings of the same kind in the same garden. Okay. So it will require a lot of ways. Let's first see problem F. Asks problem F, variety of digits. Find the given are m digits ci. M digits, m is pretty small. Find the sum modulo this of all integers between 1 and n inclusive that contain all of ci when written in base 10. This problem is very math heavy. I don't like this. Virtual standings. Solved it. 3 of the guys solved problem here. 25 rank. I think I'll be in the top 30 up until the last. If it's a pretty bad problem. Find the sum modulo of all integers on that control of CI. Let's try problem G thus. Just Takahashi has A. apple seedlings, B. banana seedlings. At least one seedling must be planted in every garden. It is not allowed to plant two or more seedlings of the same kind. Can you do some kind of a DP? No. It is not necessary to plant all the seedlings he has. How many ways are there to plant seedlings to satisfy the conditions? Okay. So every garden should have can have at max three seedlings. Every garden can have at max three seedlings and at least one seedling. At max 3 seems at max 3 and at least one seedling and at most 3 seedlings. Now how can we solve this? Input contents in ABC. Okay. At least one seedling must be planted in every garden. Cool. It is not allowed to plant two or more seedlings of the same kind in same garden. It is not necessary to plant all the seedlings he has. This is also. I think I will not be able to solve this problem in the given time period. So I think I should just stop here the screencast because I will not be able to solve problem G which no one has solved, or problem F is pretty bad. But I don't like this, and the guys who are at the topmost position have only solved problem F. and problem G has been solved by no one, so I think I should just stop here. Thanks for watching my video. Let's see you. I will see you in another screencast. Thanks for watching my video.